In today's lecture, I'm going to teach you how artificial intelligence techniques we can apply for stock market prediction. So during the last lecture, you have learned the different artificial intelligence techniques, machine learning techniques, deep learning techniques, and so forth, really for basic theoretical applications such as exclusive O and so forth. Today, I'm going to use one of those artificial intelligence techniques for stock market prediction. I'm going to cover, of course, a little bit of introduction to the parameters involved in predicting stock market values, depending on the historical patterns and depending on the current scenario, what is going to be really tomorrow's stock market prediction. I'm going to use different machine learning techniques, but in this case I'm going to use one technique first, and so that you understand how we can predict the stock market. Machine learning techniques thoroughly based on two important factors, quantitative and qualitative factors. So as far as historical patterns that is available, that means we have quantified data depending on the parameters in the stock market use. But qualitative factors thoroughly depends on really scenarios that can happen and sudden changes sometime, but sometime periodical changes, such as really changing of the prime minister or cabinet once in every 4 years. So then quantitative and qualitative factors, depending on that, of course, we have to apply different machine learning techniques. In today's class, what I'm going to do is how we can predict the stock market taking into consideration pattern history. All patterns I have already extracted from stock market during previous years, most probably 5 years, 6 years, 10 years. I have 1750 pattern set which I got really from the stock market. In case of prediction using pattern history, yes, we can apply really simple machine learning technique. That's what you are going to learn. But in case we have to introduce qualitative factors into really quantitative factors, then how to integrate this one into intelligent system. We have to look at it. Usually we have to look at it hybrid intelligence techniques, because decision making is based on two important factors, quantitative and qualitative both. So since we have historical patterns, so that means really from one side we have prediction based on the supervised learning. So then in case of qualitative factors to include, then it becomes semi-supervised deep neural networks or deep reinforcement learning. So I'm going to conclude really based upon really how successfully we can use machine learning techniques for stock market. During past few decades, different mathematical models have been used for optimal decision making for stock market prediction. Statisticians, they have used time series analysis techniques and multiple regression models for the past 4-5 decades to predict stock market prediction. But there are some drawbacks on that. So then in recent years, researchers found out that really artificial intelligence techniques would provide really better decision making in terms of stock market predictions. Particularly in this lecture, I'm going to use automated neural system in order to predict stock market in coming days in the future. For that, of course, first time really I'm going to use just quantitative factors. That means really historical patterns. We have really patterns, stock market pattern yesterday, day before yesterday, and then for past month and past years. So that means really what we have is labeled pattern. So labeled pattern set. So that means really we have all input parameters which influence the stock market prediction, as well as the output, what we want. So that calls as teacher output. But in case of qualitative factors, subjective measurements, that means really what we are going to have is unlabeled pattern set. So is mainly due to uncertainty in the society. So in those cases, of course, it is highly unlikely we can use feed-forward neural networks, we must go for some deep learning techniques. What I will introduce in this lecture as a suggestion for the coming lecture, because in this lecture what you are going to learn only quantitative. In general, therefore, automated neural system for stock market prediction is governed by two important factors: objective measurements and the subjective measurements. So the objective measurements completely based on the parameters used to measure stock market prediction. So then objective measurements, that means they are labeled. In our case, I'm going to use 1750 pattern set, historical pattern sets. But when it comes to subjective measurements, of course, we might have labeled and as well as unlabeled, such as selection of the cabinet and prime ministers once in 4 years, known to everybody. So therefore, stock market falling and rising will depend on the type of cabinet to be appointed. So therefore, of course, really, we might have certainly patterns on those days, and then we can label. That means what we have really labeled pattern sets. But sudden changes, such as really prime minister resign or coronavirus, that means really we don't have data beforehand. We don't have stock market data beforehand, then they are considered as unlabeled. So therefore, in this lecture, I'm going to use a simple data model based on objective measurements. That means really historical patterns. We have attributes which determine a stock market prediction. So then highly governed by the mathematical equations. So therefore, directly we can use machine learning techniques such as multi-layer perceptron, feed-forward neural networks, support vector machines, and neuro-fuzzy systems such as ANFIS. So then, yes, fuzzy systems might be involving really, of course, as I said just before, periodically cabinet ministers, prime ministers will change. Then such effects will have a direct influence into the stock market prediction. But other sudden changes, uncertainties occur, really, of course, should undergo deep learning. So in this example, as I told you before, I have collected 1750 data or patterns from previous stock market values. So that means over the period of time. So then data have been collected. Once we have data in our hand, then we have to decide what would be the inputs and what would be the outputs of the neural network to be produced. So then in this case, we have known pattern sets, labeled pattern sets. So therefore, we have to decide what are the inputs which make really influence on stock market prediction. So output. So then we have to decide. Once we have chosen, then we might need to go through some pre-processing of data, because we are going to use in this case feed-forward neural networks with back propagation algorithms. So then how we can prepare raw data, inputs and outputs for as input to the neural networks and the outputs. In this case, we have also output, target output, to teach output is provided. So then based upon that, of course, we can think about what kind of artificial neural network architecture and topology used, and then we can train all 1750 patterns and test and validate would be the prediction for coming days. So what are the share market data used? Attributes. So of course, these are the attributes I use in order to implement or in order to use machine learning techniques. So all share price index, sensitive share price index, daily turnover, number of shares traded, number of trades, market capitalization, turnover ratio, and sectorial indices. So we have to choose what are the outputs. Of course, all predictions based on in this case really based on really whatever I have extracted from stock markets, all share price index and sensitive share price index, that shows really what is going to happen in coming days when it comes to stock market. So then others we can consider as really. So therefore, output data, known target, teacher output, all share price index, sensitive share price index. Those are the two output data or known target. Then the input data daily turnover, number of shares traded, number of trades, market capitalization, turnover ratio, and sectorial index. In order to produce input compatible to neural network we are going to use, so in that case, yes, we have to somehow prepare our data set which can be used by the neural network in order to train whole pattern set, 1750 pattern set. So then there are three basic or primitive mechanisms used when it comes to raw data preprocessing: linear and non-linear models, principal component analysis, wavelet transformation. Of course, linear and non-linear models are quite common to use, but principal component analysis is also used because we can find out what are the most influential parameters out of input data, and then we can give really more weight onto those parameters compared to least involved parameters in stock market prediction. So the principal component analysis we can use, but complex transformations techniques also you can use: wavelet transformation, discrete wavelet transformation, continuous wavelet. I'm going to use in this case simple linear model. Why? Because we have full historical pattern set, all input data, and known targets. So therefore we can simply use a simple linear model, but yet we can utilize neural network in order to predict stock market within coming days or within 200 days, because I have 1750 patterns. So then therefore we have two outputs, y1, y2, and then input data, as you notice that we have 6. In order to provide meaningful data, input data to the neural network, yes, our expectation is to look at the evolution of neural network in coming days. So therefore, if we look at today's and yesterday's stock market values, and then we can have a better judgment on what is going to happen tomorrow and in coming days. So therefore, simple mathematical formula I am using. What is that? I will take the difference between today's values and the yesterday's values, and then look at whether tendencies to rise the stock market or fall in the stock market and so forth. So based upon that, a simple mathematical formula is used in order to get the difference between today's values and the yesterday's values. So likewise we have 1750 patterns to. But having considered really the difference, yes, another important thing that really we have to consider when it comes to input data for neural networks, so we have to look at how to normalize all inputs for each output. So one of the cases I am showing really in the slide, so that really you can see that with respect to the output, how particular parameter, input parameter varies. So in case stock market rises, DXY most probably falling, so then in that case new input range is between 1.0 0.5, and in case both are rising, so likewise of course we can find out about 5 different cases of similar nature in order to normalize all inputs for each output. We have 2 outputs. Then when it comes to target values, teacher output, yes, we know also very well that really yes, we are going to use really sigmoid activation function. Therefore target value must be chosen within the range of sigmoid activation function, as I explained to you in the previous class. So these values shall be in the range of -1 to +1. So then target value is calculated based on the maximum out of really 1750 or within 1 month. So then in that case dyi divided by maximum, we get really the target value to be achieved. So then we can take really whole complete data set or whole pattern set in order to analyze, so that you can get really stock market prediction for tomorrow or 1 month or 200 days or 365. So sample pattern set, just to show that how we obtain that. Of course 1750 patterns, and number of input units is 6, x1, x2, x3, x4, x5, x6, and then y1 and y2 as our outputs. The way we have to prepare really the pattern set, for neural network simulator. Of course, we have used Java neural network simulator in the previous class, so I'm going to use the same. In that case, first 6 columns show input data x1, x2, x3, x4, x5, x6, and then the 2 last columns show really the output data. So then we have all 1750 patterns we are going to use. And when it comes to training, usually we take out certain randomly taken out really pattern sets in order to test really in the end, after train your neural network really behaves according to the target output given. So data models you can use for this kind of applications can vary, but in our case full historical pattern set is available. Therefore we can use feed-forward neural networks, or so-called multi-layer perceptron, so with backpropagation algorithm. But for real-time analysis, most probably support vector machine will be very useful. But in case fuzziness is involved, such as I told you, like once in 4 years, 4 to 5 years, prime minister will change, and then the cabinet will change, then fuzziness is there. We can incorporate those as well. But in this particular application, in today's discussion, what I am bringing is only multi-layer. So we have 6 input parameters, and then 2 output parameters, teacher outputs. So then accordingly we have 6 neurons in the input layer, and then 2 outputs in the output layer. We can have number of hidden layers introduced in order to converge neural networks based upon really training of a whole pattern set selected. Yeah, so usually when it comes to this kind of application, this is just as you notice that really full pattern set is available, so therefore one hidden layer might work quite perfectly. So then I started varying number of hidden layer neurons, and then from 6 we can see that neural network converge. Not only number of input, number of neurons in the hidden layer, but we can still change also learning rate as well, between 0 to 2 you can change, and in case of this Java neural network, so that really we can look at it when clearly neural network converge. What is the meaning of that? Actually, once you ask the neural network to train using 1750 patterns, the mean square error should be 0 with the time passes. So during number of cycles trained, so it should reach near 0, such as 0.001. Then we can consider that neural network is fully trained, and then you can utilize the trained neural network for future predictions. So future stock market predictions. I have used Java neural network simulator, which you have already used in the previous class. So I'm just using different input data now. Input neurons, the number of input neurons are different, but then as you notice that the colors indicate that how the weight adjustment done during the training, so that really yes, neural network converge after 100 cycles. So then therefore of course we have fully trained neural network, so that we can use. So then depending on really the scenario, of course depending on what you want, of course certain number of days you can take really randomly and see how the predicted output work with the target output, which is already available from the neural network, from the trained neural network. So then different 200 days I have taken, and then see really how closely predicted output vary compared to the target output produced mathematically from the teacher output given. So that's how really you can see that you can utilize feed-forward neural network backpropagation algorithm, also called MLP, in order to predict the stock market variation within 200 days. So future 200 days, 1 day or 2 days, or 200, 365 days. So just I have only, but this will work as far as you use really entirely available known pattern set, historical pattern set, but that is not the only factor influencing to decide future stock market predictions. tomorrow's stock market prediction depending on really some subjective measurements. As I told you, in case of prime minister and cabinet change once in 4 or 5 years, we have the historical patterns, what has happened during those days. But sudden the prime minister resignation and coronavirus, that clearly influence stock market prediction. In that case, how we can integrate these factors into the intelligent stock market prediction systems. There is no doubt that really we have to use deep learning techniques, because nothing measurable we have in the history. So then all uncertainty of stock market depends on a few factors. These are basics. One, socio-economic conditions, political situation, such as Dr. Mahathir resign. So then performance of public listed companies, the activity of foreign investors, such as really in Malaysia you have Intel, and then probably there are some issues really in Intel in Silicon Valley, and that might affect really activities in the Malaysian context, and in international scenarios such as COVID-19, coronavirus. So then political situation, international scenario will have a clear impact into the stock market prediction, and that cannot be done just using feed-forward neural network, because in that case all patterns and target outputs are known, but at the moment, at a given instance, some uncertainties occurs. Of course, for that we have to use somehow deep neural network learning model. Not only deep neural network, we have to use hybrid mechanisms. Why? Because we have historical patterns, but unfortunately the situation occurred now is not reflected in any of the historical patterns. Therefore, of course, really we have to embed both semi-supervised deep reinforcement learning. That's the part really we have to, that's the example we have to take in the coming lecture, how we can integrate these qualitative factors, so-called unlabeled data. So in conclusion, we could manage to prove that really MLP, multi-layer perception, we can use for stock market prediction as far as we have labeled data. That means we have full historical pattern set. But in case of uncertainties occurs, we might not have labeled data. What we have unlabeled data, then we might need really utilization of deep learning. Machine learning technique might not work. So then therefore we have to use some hybrid deep neural networks. All stock market values used in this lecture are taken from the below publication. So whoever want to really go through complete details about how I have used multi-layer perception for stock market prediction based on historical patterns, you can find out in this article. Thank you for listening. If you have any question and answers, please raise now. Thank you so much.